Alright, now that we know what parallel and perpendicular lines are, what they look like, what their slopes are, we can find equations of parallel and perpendicular lines. For this first example, it says, write an equation of the line containing the point -1, 2, and is parallel to the line 3x plus y equals 5. Then we're going to do the same thing, but we're going to do a perpendicular line. How we start is, first we have to identify the slope of the first line, right? We're going to make a new equation for a different line, but I have to know what the slope is of this line to be able to do that. So I'm starting with 3x plus y equals 5. I want to get y alone, so I subtract 3x from both sides, and I end up with y equals -3x plus 5. The slope of this line is -3. Alright, now I have a slope and I have a point. I can make an equation of a line. Now, sometimes I have students confuse this 5. There is a slope, there is a y-intercept, but this is a different line. This is a line we already have. We want to find a new line that is going to be parallel to this. And to be parallel, it's going to have the same slope, but a different y-intercept. Okay, we will not be using this y-intercept to make our equation. So again, using the slope and my point, I have x1, y1. And since I have a point and a slope, I'm going to use my point-slope form to make my equation. I'm going to start with y minus y1, which is 2, equals my slope. Since it's parallel, it's going to be the exact same, times the quantity x minus x1. I'm subtracting a -1, and then I'm going to simplify this. So subtracting a negative, we've talked about before, is going to become addition. It's going to be x plus 1. And I'm going to go ahead and distribute that -3 into my equation. So I have y minus 2 equals -3 times x, and -3 times a positive 1. Lastly, I want to add 2 to both sides to get it into slope-intercept form. And y equals -3x. -3 plus 2 is -1. And there you go. That line will be parallel to this line. They have the same slope, different y-intercepts. And now I want to do a perpendicular line. It's the same equation here, but now it's going to be a line that's perpendicular to this one. So we already have the slope, we already have the point, but we want a perpendicular slope. So Rm will not be -3. Rm will be the opposite reciprocal. So opposite meaning this is negative, my new slope is going to be positive. This is 3 over 1. My reciprocal will be 1 over 3. So that's the slope of our perpendicular line. I'm going to fill it into my slope, our point slope form. Y minus, I still want it to go through this point, so y minus 2 equals my perpendicular slope times x minus a -1. That's still going to become plus 1. And I'm going to distribute that 1/3 in. Y minus 2 equals 1/3 times x, and 1/3 times 1 is just 1/3. And then I add 2 to both sides. So that'll be 2 1/3, or y equals 1/3 x. So 2 plus 1/3 is 2 1/3. I'm just going to go ahead and change this into an improper. So 3 times 2 is 6, plus 1 will make that 7/3. There you go. There's my parallel slope, or parallel line, and my perpendicular line. Why don't you guys go ahead and try the next example and see how you do. Alright, this example is the same as the one above. We have a point, and we want to make a line that is parallel to this other line. So first we need the slope of this line. 2x plus 4y equals 5. I need to get y alone to get it into slope-intercept form. 4y equals negative 2x plus 5. I divide both sides by 4. And y equals 2/4 is the same thing as 1/2. We can divide out a common factor of 2. X plus 5/4. The slope of this line is the coefficient to the x. M equals a negative 1/2. So to have a parallel slope, it'll be the exact same. Our new line will have a slope of negative 1/2 as well. We want it to go through this point, and that's what we'll plug into our point slope form. Y minus y1 is 4 equals negative 1/2, our slope, times x minus our x value. And then we're going to go ahead and simplify that into slope-intercept form. I'm going to distribute that 1/2. Y minus 4 equals negative 1/2 x. A negative times a negative will end up positive. I can put this over 1. Multiply the numerators. 3 times 1 is 3. 2 times 1 is 2. Lastly, I need to add 4 to both sides. And remember, 4, I could change to have a common denominator of 2 by multiplying by 2 over 2. Same thing as 8/2, which makes sense. 8 divided by 2 is 4. So really I'm adding 8/2 here. And I end up with y equals a negative 1/2 x. 3/2 plus 8/2 is 11/2. And there you go. Same slope, different y-intercepts. Part B, we want a perpendicular line. This is the same as part A, so we know the slope was negative 1/2. To have a perpendicular slope, we want the opposite reciprocal. This is negative. My new slope will be positive. This is 1 over 2. The reciprocal is 2 over 1, or just 2. Right? 2 divided by 1 is just 2. Same thing. I've put it into my point slope form, which is y minus my y value equals my perpendicular slope times x minus my x value. Distributing, whoops, that's minus. 2 times x, 2 times a negative 3, and then adding 4 to both sides. I end up with y equals 2x, a negative 6 plus 4 is negative 2. And that line should be perpendicular to our original line. So there you have it. The steps are: find the slope of the line, the original line. If you want a parallel equation, you'll have the same slope. If you want a perpendicular equation, you will have an opposite reciprocal slope. Plug it into your point slope form using the point you want your line to go through, and then simplify down to slope-intercept form.